Assalamu alaikum. It has been a long time, and today we will be focusing on a very important topic for math O levels, and it appears in paper 1 and paper 2 as well, and that is congruency and similarity. Now, in this topic of congruency and similarity, we will be discussing what congruency is, and it's specifically in mathematics O level. It comes related to the triangles. तो हम उन triangles को भी देखेंगे. How do we identify when a triangle is congruent? Then we will go towards similarity and what are actually the specifications of similarity, what are similar triangles. Then we will look at a few frequently occurring questions. And what I've done is what you won't find in any book, maybe, is that I have made those questions as concepts. मैंने उनको concepts में change कर दिया और मैंने उनको इस presentation का part बना दिया, so that you can have a full coverage. Obviously, this is not an alternative to practice. Practice is the key to gain marks in mathematics, and वो practice तो करनी बहुत ज़रूरी होगी. But what I've done is I've included more or less everything in this presentation, not only the immediate concepts, but concepts related to questions as well. So I'm really hoping that it would help you. So let's begin. All right. So the first concept is, or the first understanding is, okay, what are actually congruent figures? So congruent figures are exactly the same. They have the same shape, the same size. Any two polygons or shapes can be congruent if they're exactly the same. All pairs of sides, all corresponding angles are same. Now, the word corresponding here is very important, and I'll tell you in a while that what is actually the importance of this word and why am I actually calling this word so important. So let's move to it. Okay. Examples of congruent polygons. Now, sometimes when you look at two shapes, for example, in this diagram, you can see two shapes, they might not appear to be the same. But the definition of congruent says that they should be exactly the same. Now, there are three things. One of them is translation or sliding. Translation means you move your object some units upward, downward, left, or right, right? So if you move that object, so for example, this object and this object, if you move this some units towards your right and some units to up, this would exactly replicate on your original object. Now that replication means that both of these objects are exactly the same. Secondly, flipping. Flipping means to reflect. If one object or one shape is a reflection of another shape, then also they are congruent. Now, why is that so? Because as soon as I flip this object, it is going to reciprocate on the original one, right? For example, our two hands, they're congruent. I flip one of them and they both come on each other. Yes, they're congruent. Well, your hand is not congruent to someone else's hand. Why? Because the size might be different, or in some ways, the alignment might be different too. And then we look at turn. So turn means we are actually rotating the object. And once we rotate it, if it exactly reciprocates, exactly replicates, it replicates on the original one. So yes, it is congruent. So through these three things, translate, reflection, and rotate, you can understand congruency. Now, as I already mentioned in the beginning of this video, that we will be looking at triangles for our math O-level syllabus. And one of the, what we can say, conditions of congruency is SSS. It is popularly known as SSS, and that is an abbreviation, actually known as side, side, side. Now, what do we mean by side, side, side? That all the three corresponding, again, I'm using the word corresponding, and over here, I'll explain you why am I using that word specifically. So side, side, side means that the three corresponding sides, they are equal. In this case, GH is equal to PQ, HF is equal to QR and GF is equal to PR. So that means that this is a congruent triangle. Now here we will look at the word corresponding. Now, for example, okay, if I have two triangles, let's take the same triangles. G, H, F. Let's take another triangle. The same one, PQR. But let's change it a little bit. All right. So what are we going to do is, let's say this is P, Q, R. So if GH and PQ are equal, after GH, what do we have? We have HF. So I'm going like this, and then we have HF, right? Over here, after PQ, what do we actually have? QR. So yes, it is a similar thing here. So this is actually what is the meaning of corresponding. It should be in the same direction. It should be in the same. If we are moving clockwise, then the other triangle should even move clockwise. For example, if it was like this, that PQ is equal to GH, but actually HF is equal to PR and QR is equal to GF, then it wouldn't have been congruent because the corresponding sides are not equal, right? We're not moving in the same direction. So it's very important to see that if after GH, the next side, the similar side should be HF. It cannot, and here it should be QR. It cannot be PR. Okay, so that is something very, very important to note, right? So we will carry this concept in our future conditions as well. Let's move towards the next condition, and that is side angle side, which actually means two sides, they're equal, and the angle between them. This order again is very important. The order, the corresponding sides, that's very important. So it's a side, then an angle, and then a side. So DF is equal to CB, then the angle D is equal to angle C, and then CA is equal to DB. That is side angle side. Then we come towards angle side. Two angles and a side after that, right? So for example, in this case, angle C is equal to angle X. See, they have actually changed the shape. They've rotated the shape. They've rotated this shape to make this shape. And we have already studied that in rotation, the shapes are actually congruent, right? So after C, if you go, then you find M. Here you can find T. And then M and D are equal. T and G are equal. Then D and G are equal. So it's very, very, very important to see that alignment. And there is another property, or we can say another condition, that is known as RHS. And why is it known as RHS? Because R means right angles. So two right angles can be congruent if their hypotenuse is same, and any other side, any one more side, here it's that side is referred to as leg, can also be same. Then the two triangles are congruent. Okay, so we have used all these properties, SSS, SAS, angle side angle side, ASA can even be used, RHS, all these properties. And we even know the definition of congruent. And there is one abbreviation which you can use, CPCTC. That means corresponding parts of congruent triangles are even congruent. They are even same. Through this property, you can actually find the other sides. If there is a side property, that means that other corresponding parts, that are the angles, they're also equal. And all these things. If you have AAS property, then you should know that the other two sides of the triangle will also be equal because the other two corresponding sides, because the triangle is congruent. Okay. Now let's look at this. If it says the triangle REM is congruent to the triangle FEM, so what can you say about this triangle? Now, you know that the two triangles, they are congruent. So now let's use the CPCTC rule here. All right. So the CPCTC rule says that if the two triangles are congruent, their corresponding sides are even congruent, right? So that means RE will be equal to FE, RM will be equal to FM, and we can see that EM is actually the common side. We can also say that EM is the bisector, the angle bisector, or we can even not only the angle bisector, it is even bisecting the line RF into two equal parts. Bisect actually means to divide a line into two equal parts, and so this is 90 degrees. And what can be concluded about the triangle REF? It is definitely an isosceles triangle. So if two figures, they share the same side or the same angle, then the shared sides or the shared angles, they are congruent to each other. That's a very important thing to understand, right? Okay, here we can prove the triangles are congruent. How can we prove it? PS, QP are equal side, angle Q, angle S are equal angle, and QR and SR are equal side. So side, angle, side. One more property, PR line, PR is actually bisecting the angles. So the angles are being divided into half. So these angles are equal, then a side, then an angle. So angle, side, angle. We can even say angle, angle, side. So can be proved, one diagram can be proved in multiple ways. Here we can use the RHS property. The hypotenuse is same, both are right angles and one side. Well, we can even use the side angle side property. Again, multiple properties. Now let's come towards the other concept. So here we are done with the congruency concept, and congruency is really easy, like it ends here. But you know, similarity, it's continued further. You can watch my other videos, which I'll be making on the volume and area for similar figures with word problems and everything. But here I will be covering the basics of similarity. So one thing over here is, in similar figures, their corresponding angles, yes, they are the same. But the corresponding sides are not the same. They are proportional. They're in the same ratio. What do I mean by they're in the same ratio? For example, if you have one side 4 and the other side 2, that means the sides are being doubled. So the one side with 3 will have a corresponding side with 6, right? So the ratio of the lengths of corresponding side. That is the similarity ratio, and that is why we call these triangles similar. Okay. Determine whether these triangles are similar. If they are, write a similarity statement and give the similarity ratio. All right. So first we need to check whether if not only the angles, but the corresponding angles are equal or not. If they are, then yes, it's similar. Let's start with B. We can see that B is equal to E. And then if we move, we see that BC is actually 12. And here, the next angle is D. And yes, here C is equal to D, right? And then F is equal to A. Now, what we need to check is that is the ratio of BC and DE matching the ratio of BA and EF. Now, how did I decide upon these two sides? It's very easy. Between these two angles, the angle with 2 lines and the angle with 3 lines, you have 12. Here you have 16. And here between the angle with 2 lines and 1 line, you have a 20. And here you have a 15. So let's just check over their ratios. All right, so here, what do we see basically? So let's check, this is 12. And this is 16. So 16 upon 12. Now 16 upon 12 is not a compulsion. You could have written 12 upon 16. But if you're writing 16 here on the top, so here also you will write 15, right? On the top. Sorry, you're writing 16 on the top, so you'll write 20 on the top because you've taken this triangle first. And 20 over 15. So 16 and 12 come in the table of 4. This becomes 4 by 3. And 15 and 20 obviously come in the table of 5. This becomes 4 by 3 as well. So yes, they are similar. Right, you have certain properties, angle-angle similarity. If 2 angles are congruent, and since the triangles angles sum up to 180, then the 3 angles are actually the same. Side angle side. Now 2 sides over here, I've already explained you the orientation of side angle side through congruency, but here the 2 sides will be in the similar ratio. Side, 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 again, similar ratio. Now, this is the point I wanted to actually come to, and I'm finally on the final stage of my video, and that is to understand the frequently occurring questions in the paper. Now, you have a right triangle similarity coming in your papers. Now, how can you actually prove that these two diagrams, they're similar, and exactly what triangles are similar in this case? Right? So we will be looking at this case. So let's say here we know that the bigger triangle, this triangle, is similar to this triangle. And we already have one of the angles. So we can easily say that what 2 sides will be proportional. So let me just come to this. So what I'm saying is that this triangle is similar to, let's say that is given to us in the question, this triangle. So in this case, which side will be proportional? We will be sure that B is proportional to C. Now, why can I say that? Because B is opposite to the 90 degree. Again, B corresponds to C. and C is opposite to this 90 degree. So we know that these two sides are similar, and we can set up the proportion of B ratio C or C ratio B, right? We do not have enough information to solve the question because obviously we are looking more towards concepts in this video. But these are the kind of questions you can expect, and then one of the values can be given to you, and then you can be expected to find the other ones, right? Okay. The other kind of question we have that if two lines are parallel, now this is very important. Here, all your angle concepts are even tested. So if two of the sides, they are parallel and the line divides them, so the rules of the F property, right, makes this angle and this angle equal. I'll just show it to you. Right, so this angle is equal to this angle. This angle is equal to this angle. And this is the common side. Right, so all the three angles are actually congruent. Now let's look at our last slide. That is the triangle angle bisector theorem. So this angle is actually being bisected. Now in that case, if a ray bisects an angle of a triangle, it divides the opposite sides into two segments, which are proportional to the two other sides of the triangle. So in this case, BC is proportional to CD and BA will be proportional to DA. Whenever it breaks it like this is a theorem, and again can be tested in your papers. So that's it for the video today, and we will be covering these concepts in future video through questions even. So stay tuned, and if you want any further explanation or help, you guys can always email or comment on the videos, and those videos will be posted accordingly. Thank you so much. Have a good day.